Stanford University.
Okay, let's get started. Welcome again to Lecture 4 of CS 193P. Today, some of the topics we're going to cover are how to build an application, so the basic building blocks of an application. Model view controller. This is a very important concept that you're going to take with you throughout your programming experience. Something called nib files and control and target action. So let's get started. First, some announcements. First things first is assignment number 2 is due tomorrow. So please hope things are going well. If you have any questions about it, please post on the class list. For those of you that are enrolled in the class, we have a class email address that we've already signed you up for. I'll keep any mention of it private, but for those of you that are not enrolled in the class and for those of you at home, you can try this. The auditors in the class, please take a look at cs193p-auditors@lists.stanford.edu, and we'll do what we can to help you on that. And a final little thing I want to talk about is WWDC Student Scholarship. So for those of you that are familiar with WWDC, we've talked about it a couple times. It's the Apple Developer Conference that's held every year. I don't know what the cost is. It's fairly expensive, a grand or a couple grand maybe. But for students, there's an opportunity to get additional funding from Apple if you meet some criteria. If you fill out a form that they'll pick some. I'm not sure how many, but apply today because it's due tomorrow, and you can apply online right here. Yes. Why would we want to go to that? So WWDC, they'll talk about all of the new technologies inside the iPhone and inside the Mac. There's all kinds of workshops to help you get through your programming, help you solve different kinds of problems. Introduce you to all kinds of different technologies. So it's an information fire hose. So drink from the fire hose. So today's topics, once again, we're going to talk about the application lifecycle and how to build an application. Model view controller. Interface builder and nibs, which is the Apple's paradigm for building views. It's a graphical tool. Controls and target action. So this is how you're going to actually wire up an event from a UI element to some code in your application. And we'll take a look at Hello Poly really quickly. This is your assignment for this week, due tomorrow again. So stick around till the end, and we'll give you some little hints in case you need some help. So let's get started. First, a little review from last week. Memory management. So alloc and init, very important when you want to create an object. Alloc assigns your memory, init helps set up your object. For your objects, you're going to want to override init, not alloc, and init is your starting point for setting default values and stuff like that. One additional point I want to talk about with init is that by default in Cocoa, when you initialize an object, even if you don't do anything to assign a value to an instance variable, it automatically nils out. It automatically assigns 0 to all of your instance variables. So it's a convenience. You can count on it. We do all the time. And of course, if you don't assign things, we've talked about in the past that nil is this special case where you can just kind of skip over things if things are nil. But again, so your object gets cleared out when it gets initialized. Retain release is a paradigm for counting memory. So we use retain count. When you call retain on an object, its retain count gets bumped. When you call release on an object, its retain count gets decreased. And when that gets 0, and that goes down to 0, your object is deallocated. Again, you never call dealloc directly unless you're subclassing dealloc to release any instance variables. And finally, auto-release is, as Evan put it last week, is magic. And when you auto-release, you can substitute auto-release for release if you want that object to stay around until the run loop is complete. And then at the end of the run loop, the objects get released. And if that's the final retain count, then the object gets deallocated at that time as well. Setters, getters, and properties. So this one, very useful as you go forward. There's a standard format for setting up setters and getters on objects. If you want to access an object's age, as for example here, The format is the return value, which is the type, followed by the name of the parameter. And if you want to set the value, it doesn't return anything here, void. You call it setAge with a capital A, and you assign the value as whatever type it is. And then properties, of course, allow you to access all of these through dot syntax. And again, you're not actually accessing the ivars directly. These are conveniences for overriding these different methods. So age, here we're getting the age, which is the age method above. And here we are setting the age, which is the setAge. So any questions on last week's topics before we move on? Memory management, last call, setters, getters, properties. Everybody's completely familiar with this? Great. So here we go, building an application. Let's take a look at the anatomy of an application. So what's your application made of? What's inside of it? You may notice, this is true on the Mac OS, this is true on an iPhone, that your application is not just one file, it's called a bundle. And inside that bundle, there's different kinds of files, one of which is named the same as your application. You also see different things like plists and resources. Well, what are each of these different things? Well, first, and this is the piece you're probably most familiar with, your application is made of compiled code. So your code that you're writing gets compiled down to object code and gets executed. It also runs against codes in frameworks. So your application links against frameworks, and those tend to live at the system level. And then your application calls those and executes that code. Nib files, this is something we're going to talk about today. It holds a lot of your UI elements and holds relationships between your UI elements and some other objects in your application. So you can instantiate objects via nibs. You can hook them up together, and we'll show that in a little bit. Resources, so typically there's a resources folder inside of an application. Is that true on iPhone? Yeah. So there's a resources folder, and inside that you'll find images, sounds. You'll see different kinds of folders that are named things like English.lproj, French.lproj. If you're doing localization, which means if you're taking your application, shipping to different countries with different languages, you'll see these string files. And then an info.plist. Every app has an info.plist that basically describes to the operating system how the application is configured. So some things, well, we'll get into that. So Evan showed this last week. Here's the application lifecycle. So when you launch an app, the first thing it does is it comes up, it gets initialized. It loads the main nib, again, which we'll see today. And then it starts this thing called a run loop. So it waits for an event. When an event comes in, it handles the event, and then it lets your application know. And it lets your application know via some of the connections you make in your nibs and via other kinds of timers and notifications and different stuff like that. But what happens there is you go and you handle an event. This is where your code runs, and it loops back, waits for another event, and keeps going until the user finally hits the home button on the iPhone, and then the application exits. This is where most of your application lives. Now we'll show you where to tap in for some of this and some of this in a few minutes. But we'll talk first about UIKit framework. So actually, just a really quick note on this. For those of you with the Hello Poly demo, you'll notice that we're actually linking against Cocoa/Cocoa.h. That's a mistake on our part. It should actually be UIKit/UIKit.h. And the difference here is Cocoa is the framework on the Mac for doing standard development, getting all the UI pieces. On the phone, it's UIKit. So UIKit provides the standard interface elements you're going to use. And another important thing to note about UIKit is this is Apple's framework for different UI pieces. If you've used other languages, you may try to solve problems. You may see problems solved in a different way than UIKit solves them. You may see a lot of things that are familiar. But the thing to note is that on each of the different platforms, well, particularly in Cocoa, don't try and fight what you see. If there's a paradigm like delegation, or if there's something that you're not that you want to try and do something differently because of something you've seen in Java or somewhere else, take a step back, take a look at UIKit, take a look at the frameworks, and see if you can rethink your problem in a way that fits this. And if you have any problems with that, of course, come to us and we can help you with that. But yeah, this is a well thought out paradigm. We use it all throughout the Mac, all throughout the phone, so very useful. So UIKit, as far as the application lifecycle goes, UIKit starts you up. So when a user clicks on the icon in the iPhone's launch screen, it starts your application, and then it creates an instance of UI application. Now, every application has one single instance of UI application. It's called a singleton. The design pattern is called a singleton. If you ever need to access your UI application instance, you can actually get to it by calling open square bracket UI application, shared application, and that will give you your instance of UI application. You can then ask it for different things like its delegate. You can query it for different states and stuff like that. So UIKit then, so it launches, it creates this UI application subclass. It manages the life cycle, so the run loop. It dispatches events to your objects, to your delegate objects and your control delegates, your control targets. It manages things like the status bar and the application icon badge you see in the launch screen. And it's very rarely subclassed. So there's things you might think, you know, I want my UI application to respond to a sleep event, or I want it to respond to, I need to know when it's going to quit. The first thing you might think of how to do that is subclass UI application and find whatever method you need and override that. But then you don't know exactly when am I supposed to call super. You don't know, there may be different ways of cleaning up the application. What you get as part of UIKit and part of UI application is you get a delegation. What delegation is, which we'll talk about now, is an ability for one object to tell another object about significant events. So in the UI application space, let's say when you set up your Xcode project by default, you're given a UI application delegate by default. And I think the template even gives you some basic, some empty functions that you can fill in. And there's more that you can get to. But basically, you don't subclass UI application. Your delegate method implements different methods, and you get messages from the UI application. It avoids the need to subclass, and you'll see it throughout UIKit. So table view. Table view is an example where you actually don't want to change the behavior of UI table view, so it's very rare that you're actually going to subclass that. But the table view needs to know different things from you. It needs to know how it behaves. It needs to tell you when objects move around. It asks you for different pieces of information. And all of that's set up via delegation. And then text field, one sec. And text field, also very similar. You think text field might be a simple thing, but it's pretty complex in terms of handling different kinds of touch events and magnification and stuff like that. So all of these things are dealt with delegation. Yeah?
I really don't understand delegation at all.
Okay.
I don't get it. Like, why?
Sure. So the point is that he doesn't really understand delegation at all. So to make it a little clearer, I don't have a drawing board here, but I do, but I don't think the camera's going to catch it. Let's say I've got object A. Okay. In this case, it's my UI application, and it needs to tell someone else about different events. So actually, let's look at the example. All right. So let's look at this one. I have an application. It needs to tell me that things are happening. So did finish launching, will terminate, will resign application, or yeah, will resign active, handle open URL. All these different things are things that my running app needs to know about, and it needs to know about without being able to subclass UI application. How can I explain this a little more? It's basically the ability for, object A to tell object B about something happening. And when when object B handles that message, it returns back to object A to continue what it was doing previously. So it's kind of a hook, right? It's a hook for one object to say, go do this, this is what I'm about to do, and then return to me when you're done. So now that returning is automatic because what happens is you're just implementing a method that gets called. So application A, in this case, it's doing all this initialization, and the application says, I'm about to finish launching, I better go tell my delegate. The delegate goes and initializes whatever he's doing, and when he's finished, the initialization step completes, and then the run loop can start up. Does that clear things up at all?
I understand it's sort of separating code from the object,
right?
But I don't get why you have to separate. Why can't you just keep it together?
Well, this is an example of, sorry, so the question is, it makes sense why you want to keep the code separate, but why not just put it together? And the easy answer is reusability, right? I could take the UI table view as an example. I could take the UI application example. But if we're not going to subclass UI application, there would need to be, every application would need to be overridden to get different behavior for each instance. Let's take the table view example. I find that one a little clearer. When you use a table view, for example, in your application, your table view is going to be different than a table view in another application, which is going to be different than a table view in another application. But each one of them is going to have its own unique behavior. Now, in order for you not to have to subclass and get all of the state that a table view gets, you will set up this delegate, tell the table view to ask that delegate for different pieces of information, and then...
Why don't you just inherit all those functions and stuff?
So, in object-oriented programming, there are often cases where you want to extend or customize the behavior of an object. And one way to do that is via inheritance. There are cases where, just from a design standpoint, it doesn't make sense to necessarily inherit, create a subclass of an object. For a table view, for example, it would be really tedious if you had to, subclass UI table view all the time and sort of, deal with the dependencies that creating a new subclass can introduce. Versus, for really common things like what happens when a row gets selected in a table view. One way of designing a framework might involve subclassing UI table view and overriding some selection method. Given that it's so common and that it's not really intrinsic to the behavior of the table view, it's sort of outside behavior that's connected to the table view. A lot of these things are judgment calls. Ultimately, you can choose to design the framework one way or another way. For a lot of really commonly used reusable objects, just the design decision was made to prefer delegation over subclassing. So there's no necessarily black or white, right or wrong answer here. You could design them in different ways. This is the way that some of these classes are designed.
If I could actually just make an example here, or give you an example, would be to separate the amount of work done into different objects. So Evan and I are your teachers for this class. There's a lot of work that goes into teaching, right? So we actually have a couple TAs, Troy and Paul, that we delegate some of the work to take care of these things, right? When they're done with things like marking and the office hours and stuff like that, they come back to us with the information, and then we send it back to you. So I don't know if that makes anything clearer, but we help. We delegate some of the work to them. They can do a better job than we can.
Rather than just cloning us.
Rather than cloning us or keeping us up late at night. So there's my example of delegation. Okay, let's see. What did I miss here? All right, so the object you provide participates in the application lifecycle. Once again, your application, the Xcode template, automatically creates a delegate and actually assigns it as a delegate for your application. And then you can respond to any of these methods. And if you take a look at the headers, there's a couple dozen of these. From knowing when the device is going to go to sleep, so you can handle things like saving state. Knowing when you're about to no longer be the active application, so you can do things like if a telephone call comes in, you can do the right thing. If stuff like that, right? If you're about to quit, you get notified. And then this one's an important one. Did receive memory warning, so sometimes the system will tell you that your application is running out of memory, and if you actually run out of memory, it will kick you off and it will kill your application. But this gives you a chance to go and clean up things that you don't really need. Things that are cached, images, views, stuff like that. So well, I'm sure we'll be looking at that a little later in the course. This is also another interesting one, handle open URL. So just as a note, you can register yourself with the system and say that your application responds to certain URLs. So when the system gets a URL, it'll call you and say, hey, somebody called you with your application slash, this database entry slash this, and then you can do the right thing, open to it, etc. So that's application delegate. So now if you remember from the anatomy, there's resources, there's nibs, there's code, and then there's the info.plist file. And this is your application configuration file. It specifies things like the appearance of the icon, the orientation of the app. Is it landscape or is it a portrait? What does the status bar look like? Status bar is, of course, the bar at the top of the screen that has the time. Does the app use Wi-Fi? It's just a nice hint to the system to help get things initialized. And system requirements. So if your app only runs on the iPhone, for example, that's something that you would put in your info.plist file. And all of the keys that you specify in here are defined in the headers as well. So I would take a look at that. For those of you that are not familiar with property list, property list is basically a key value set, a file with keys and values. So, XML is a good example. In fact, I've mostly seen this implemented in XML, so it's easy to read. And then if you want to edit them, you can either open the XML file and edit the XML directly, or you can go into Edit Active Target in the project menu in Xcode, and you can get to most of these properties there. So that's the application structure. Now, model view controller. So this is it's a design pattern that you'll see throughout programming. It's been around since Smalltalk. It's been around a long time. And a lot of the tools in Cocoa development, in phone development, cater to this. So what does this mean, model view controller? Well, the basic reasoning here behind model view controller is that your view, your model, and your controller are separate. Now, what are each of these things? Well, your view, as you might guess, is what you see on the screen. Your model is actually your data, what gets stored, and your controller manages the interaction between the two. So let's take a look at this. The model manages the app data and state. It's not concerned with the UI or presentation of that data. It's strictly the data as it's stored or as it's as it's internally formatted. It often persists somewhere, whether you're writing that to disk or whether you're sending it up to a network. And the same model should be reusable or unchanged in different interfaces. So what does that mean? Well, let's say I write an iPhone application that displays a database. In this case, the database is the model. It stores the all the different records and everything. I should be able to present that information inside an iPhone application. I should be able to take that model and bring that to the Mac and display that in a completely different user interface. I can even display that in a command line, and I should be able to run commands on it. The point is that the data underneath does not change based on the presentation. So the view, well, this is the presentation. Now, it shows the user the data in an informed way, in an appropriate interface, right? So if you're doing a command line interface, the view would be spitting out the right strings. If you're doing an iPhone interface, it's using buttons and table views and stuff like that to display the information. It does not store any data, and it's reusable and configurable. So these things tend to be fairly abstract and customizable for the data. So buttons, sliders, table views, these are things that you're not going to write one kind of slider for volume and one kind of slider for equalizer. And I mean, you may want different visual treatments, but underneath the hood, they act the same. When you move it, it's going to send an event and tell your application that that value has changed. So views don't know anything about what they're representing except that they can be configured and present the data. And what's a controller? Well, the controller is the glue between the view and the model. So this is custom to your application. For each app, you're going to have different controllers that know how to format the information that comes out of the model and set up the views properly so that they display the right stuff. When the data changes under the hood, so let's say there's multiple people, talking to this database. Let's say it's network-based. The controller is the one that notices the change in the model and tells the view to update. Similarly, it's also the one that takes the events from the view, receives events from the view, and then updates the data in the model. And then typically, this is where the app logic lives, which means this is where each of your applications, this is what you implement differently. So again, taking a look at this, the model talks to the controller, and the controller talks to the model, and the controller talks to the view, and vice versa. There's no connection between these two. So a good application in this model view controller pattern has no communication between these two. And here's another visualization of it. Let's say you've got a controller in the middle. You can point to different outlets. You've seen IB outlets in your interface builder headers, or in your Cocoa headers. The outlets point to the view, and the outlets can point to the objects as well. And the view actions, the control actions, point back to your controller to do the right thing. Does anybody have any questions on Model View Controller, or MVC as you'll hear it called throughout the course? Okay. So Interface Builder and Nibs. Interface Builder, you've seen Xcode. Interface Builder is a visual tool for laying out your application, the visual parts of your application. And the files that it represents those in are called nibs. So nib files, there's the icon. You tend to have more than one nib file per application. In the Hello Poly app, we're only going to look at one for now. But this is it. It's a little sketch of your app, which is kind of cool. You'll see the extension is .xib. It used to be .nib, I think, on the Mac. Well, it's on both. It's both on the Mac. I think the X stands for XML because they've recently converted over. But these are your nib files. So the nib file helps you design the view in MVC. It helps you lay out the user interface elements. So if you've launched it, and we did on the first day, it's actually like a little scrap pad for dragging different UI elements on. So you can drag a slider onto it, you can drag a button, you can drag a text field, you can lay them out. It also lets you add controller objects. So in the MVC pattern, you are creating your views in Interface Builder, but you can also have you can create your controllers either in Interface Builder or in Xcode. We'll talk about controller objects a little more in a few days. Evan actually is a huge force behind making those happen. There's all kinds of different ways to represent data on the iPhone. And another thing nib files will do is connect the controller and the UI. So you're actually drawing arrows from instance variables in your controller to the different elements in the UI, and you're actually dragging arrows back from the UI elements to different methods in your controller. So nib loading. When you set up your interface builder, there's all kinds of different parameters you can set. There's a little information pane. You can say what initial states are. You can set a bunch of different parameters for visual configuration. When you load that nib, it actually comes back and all of your values are the same that you set in Interface Builder. All the outlets and actions that you set up back and forth, the little arrows that you draw, get reconnected. But the order with which that's done is undefined, and we'll look at that in a second. So if you need to do anything special when those nibs get loaded, let's say you need to set state. How do you do that if you don't know what order things come back? So let's say I've got a controller with a a pointer to a slider that helps me set the age. I need to be able to set the state of the age back when things are up. So UIKit, actually NSObject, gives you a method called awake from nib. And what awake from nib does is after initialization, after you've actually loaded a nib, this gets called on every object that was instantiated from that nib, and I believe the parent object as well. And you can do any customization in here. So it's kind of your hook for setting up initial state on your views and on your controllers. So default empty implementation on NSObject. So by default, you do not need to call super. So if you have a controller that responds to awake from nib in order to set an initial state, you don't need to call super here. I don't believe there are any exceptions on the iPhone.
It's still safe to call super, just to be safe.
Okay, it's safe to call super even if it's an empty implementation. So ignore me, call super, and you'll be happy. So, and then once again, at the time when an awake from nib is called, you can be sure that all of your objects have been reinstantiated, all of your connections have been remade, and it's a safe time to set things up. So, any questions on that? Any questions on Interface Builder and nibs? I'm going to give a little demo on this at the end when we talk about the Hello Poly project. So that might help too. Now, controls and target action. So this is something we also saw on the first day. And this is a way for different controls, whether they be sliders or buttons, to let your application know that something has changed. So if we take a look at the project that we're going to look at later, there are, your controller has a couple of different outlets here. Number of sides points to that, increase button, decrease button. And each of these, this is the action target stuff, is the buttons actually point back to the controller, right? So when I click on increase, when I click on decrease, methods on my controller get called that correspond to that. They're actually methods that I've physically set up with these arrows. We'll take a look at that in a minute. So controls. Now, every control responds to different events, right? This is the point of a UI control. UI control is kind of an abstract subclass of a UI view, which we'll talk about next class. But a UI control handles things like touch down, touch dragged, touch up. There's different variations on each of those. You can say, is it touch up inside or outside? So, touch up outside means the user clicked on a button and then pulled out as a way to cancel their click. Touch up inside means they actually clicked on the button and let go. There's different variations of touch dragged. There's something called value changed as well, which is a convenience on UI control. Some of them actually use it, some do not. But if you have a control that manages a value, like a slider, instead of having to respond to each of these, instead of you having to track, there was a touch down in the slider, you have to get you don't have to worry about every touch drag event and then a touch up to commit it. You can actually just respond to these value changed events. And the value changed events tell you that the state has changed without you having to know all the details. And then some of them also respond to editing events. So UI table view is another example of this. I can start editing on a table, and inside of a table I can delete items, I can move items around, stuff like that. Okay, so here's a little illustration of control target action. In this case, this is my object. There's a method called decrease that my object implements, and I want to get the event touch up inside. Right? The way I do this is, this is my object. I actually, in Interface Builder, I'm going to drag the control, I hold down the control button, and I drag from the button to the object, and I say that's the target. I then assign the action. Okay. I say what the action, the event is touch up inside. and then the action is decrease. So you actually make this physical connection between the two. Now, there's 3 different types of action methods that you can implement. Each are the same. Each are dealt with the same, but they can get different amounts of information. So the first is you can implement a method that doesn't receive any information about what happened, right? So in this case, back here, when I say decrease, I don't care that it's, I don't need to know anything else. I'm just being told to decrease. It's a single button event. So there's the first one, where it doesn't take any arguments. The second example here actually takes a sender, and the sender is the object that initiated the event. So in this case, in the case I just showed you, that decrease button would actually come in as a sender. And if you wanted to find out what the state of that button is, what the title of that button is, for example, you can actually cast that sender to a UI button and then ask that UI button any questions that you wanted to based on the headers. And the third flavor here is you can get a sender and you can get an event. So the sender is the same as it was above, but the event then can tell you things like what kind of event was it? Was it a drag or a touch up? How many different touches? How many fingers were down? Where were those fingers at the time? And all that information comes encapsulated in the event. There we go. Now, here's 3 examples here. So, once again, increase. I don't actually care about what happened other than the fact that the button got pressed. So I'm just going to add 1 when that gets called. If this was a slider, I can ask the slider for what the value is. So in our example, if you implemented, instead of increase, decrease, you implemented a slider with 3 to 12 sides, I can ask the slider how many sides that actually came back. And then if we wanted to actually ask for information on the event, if you implement that, you'll automatically get called with the 2 different arguments. Now, in the phone, it's a little different for those of you that have done Mac programming. On the phone, you can actually have multiple targets for a single action. So I can say my increase button can call this controller with this action. It could call another controller with a different action. It could even call different controllers for different actions. So I could say, when I say touch down, I want you to call this method. When I get a touch up, call another method. And again, through Interface Builder, you're just dragging these arrows, and it's going to ask you which ones you want to hook up. Different than on the desktop, where you can only have 1 target per object, per control. And each of these is set up in Interface Builder. So if you wanted to do this programmatically, it's actually, we'll get into this in a sec, which is why use nibs. But let's say you wanted to do this programmatically. Because you can have more than 1, you can actually say add target. So you call let's say the button object. You call the button object and you say add target your controller, what the action is, so what the selector that represents the method is. And for control events, and this is a bitwise OR of the different events that you want to take. Is it a touch up inside? Is it a touch drag inside, et cetera? And then a remove target is the same thing. So we'll look at the Hello Poly. Actually, before we do that, I want to talk about, so why do this in Interface Builder, right? A lot of people, I've heard this question asked a lot, which is, I can do all of the things that I want to do in Interface Builder. I could do it in code, so why do it in Interface Builder? The easy answer is that it's visual, and it makes it a lot easier for you to A, lay things out, and B, see where your connections are. You certainly can do it in code. And as someone who's used the tools for the last 9 years, sometimes I do use it. I do it in code, but oftentimes I find changing things later becomes a lot easier when I've implemented it in a nib. So get familiar with the nibs. If you want to experiment with the code, I encourage you to as well. Yeah.
Does the Interface Builder generate the code for you?
So the question is, does Interface Builder generate the code for you? And the short answer is The short answer is yes. And to get a little more detail here, the view objects, your controllers that you create in Interface Builder, all of those are archived into the nib. When you load it, they get unarchived for you. You can also get, for controller objects, you can actually instantiate them in Interface Builder. You can tell it what all the different instance variables are, and then you can say, generate a .h and .m file. And that will actually give you a template of what the code looks like. In general, you don't see, let's say, a slider. If I have a slider that actually has an action to my controller, that code won't get generated. Those connections actually get done for you behind the scenes. Yeah.
Quick addendum to that. There are some, on other platforms, other tools, there are interface design tools where you lay out your UI and then it actually writes code for you. It'll generate blocks of code. Interface Builder is not a tool like that. What it's actually doing behind the scenes is instantiating these objects, say a UI button, and then it's using something called archiving, where it basically takes this instantiated object and puts it into deep freeze and puts it into this nib file. So later, when your application actually runs, it's not creating a new instance. It's actually defrosting that object, and when it's done defrosting it, it calls awake from nib. So Interface Builder is not a code generator, if you're curious about whether that's actually happening behind the scenes.
Any other questions about Interface Builder and nibs before I show you a demo? Yeah. So the question is, if you use Interface Builder to generate objects for you, and then you finish your application and you get to the end and you decide, oh, I want to add some functionality. Will Interface Builder do the right thing by generating the right code? So if you're actually using Interface Builder to generate the code, I believe what happens is if you are generating code for something you've already generated code, it'll give you a merge window, basically. And you can actually manually say, yeah, this is right, this is, it tends to do the right thing, but you get the ability to double check, and it'll let you, line things up and make sure each of the pieces are correct.
Every time you open Interface Builder, it'll try and pick up changes from your header file. So if you've added a new property or a new action method or something like that, it should automatically pick that up and allow you to hook something up to it in your UI. If you've removed something that you had hooked up, which I think may have been sort of what happened in our Lecture 1 demo, then connections may get broken, that sort of stuff.
That's actually so a good workflow here is, you should design everything before you go implement anything. But if you're designing and coding on the fly, if you have Interface Builder open in one window and you've got Xcode open in the other window, as you're adding methods and saving, those methods show up in Interface Builder and you can just drag them. So that's pretty useful. Anybody else? So let's take a look at the Hello Poly demo. I'll just show you really quick how we're going to basically set up some of these connections, and should help you a little bit with Interface Builder. So first, here's the application. So, well, I've already got it launched. Let's actually start from scratch. So here's my project. I'm going to hit run, which actually I tend to use the keyboard shortcuts, which I apologize, but let's do that again. So I'm going to go build and go, which opens up the simulator, and here it is running. So I've got two buttons, decrease and increase, and as I hit decrease, you'll see that the shape is changing, even the name of the shape is changing. And as I go back and forth, it does the right thing. There's a few different things changing here. Of course, there's the number of sides, increases and decreases, and the drawing does as well. So that's that. Really quick to show you the nib. Where is that? I'm opening up Interface Builder. And what you see here are all of your objects. And how does this work? Well, let's just take one of these. I'm going to show you how to make one connection, and then you guys will be left to figure out the rest. So this decrease button, you'll see by default, there's a touch up inside event. I can actually make that connection by I'm holding down the control button, and I click, and I drag, and there's the decrease method, and I connect it up. And that's how you set things up in Interface Builder.
What's
Yeah.
going on like under the hood when you do that? It seems kind of magical to me.
The question is, what's going on under the hood? The answer is it's magic. No, okay. So in short, your header has to define the outlets and the actions, right? We've seen that in lecture 1. When these objects get unarchived, when the nib gets opened up, those get hooked up for you. So the nib loader says, it points things to the right thing. So it actually creates a selector, and it assigns it to the button and says that's your action when you get this event. It's the same thing that you would do programmatically. It's just doing it under the hood for you. So those add target, remove targets, that's all it's doing. That's all it's doing.
So it's a code generator.
The question is it a code generator? It's not. You're not going to see the code it generates. So it doesn't generate code.
So to clarify a little bit, it's not actually generating code. What's happening here in Interface Builder is it's actually creating a UI button instance. And if you remember a couple of slides back, there was this add target with action for control events, I believe is the name of the method. It's actually calling that method on that UI button right here, add target action for control events. So by doing that, it's telling the button, hey, when this event happens, the touch up inside, I want you to invoke this action on the specified target. So then the button, just whether the button is being created in Interface Builder or created in code, this button, because it's a control, has to maintain a list of all of its, sort of target, action, control event, combinations. So the button keeps track of that. When the button then gets, as I was saying before, frozen or archived from Interface Builder, it basically writes out that list of targets and actions. So later, when it gets reinstantiated, it's as if nothing had happened. It's as if it were exactly as it had been set up in Interface Builder. Does that make sense?
So how does the button or any other object in the window know where to search for all the possible methods? Like, why is it? How do you do that?
So the question is, how does the button know to search for all the where to search for all the methods? Well, the answer is that you actually, so in your nib, you're going to drag the arrow from the control to your target, and your target actually you define what type it is, right? So in your target, let me show you really quick. So if I click on my controller object and I look at my inspector here, ignore all the other information. You look at the class is type controller, and in my code, the controller has defined all of its actions. Now, if you remember from the first class, we had an IB outlet and an IB action. The IB action defines all of the methods that can be called on events, and the IB outlets define all of the references to Interface Builder objects. Yeah.
So in this MVC model or whatever you want to use words, does the controller have all the possible methods for every single possible object?
The question is, does the controller have every single possible method for every single possible object? No, it only has methods that it responds to. So, if your controller knows how to deal with decrease and increase, those are the only methods that it has.
So there's a controller for every single object.
There's let's go back to this diagram actually. Okay. So this is a simplification, obviously, right? Your application is going to have several of these, maybe several of these, and lots of these, depending on how complex your application is. each one, each controller should be smart enough to know how to connect one view to one model, and potentially more than that. But it's fairly self-contained, so it manages one type of relationship. If you want a different type of relationship, you tend to have multiple controllers running alongside each other. So if I have a a couple of different buttons in my view, and one does something to this model and another does something to a different model, you may want to do that through a different controller, depending on how complex your system is. And then that controller would only know how to handle one method for the view. Does that make sense? Does that help? Any other questions on this? Yeah.
Sorry.
That's okay.
Just like, so when you click the button,
yeah.
I'm sure there's a controller that says decrease or increase.
Yeah.
But I'm sure within your model, there's some kind of connection between that button class and some other class that updates the number that you actually see. So you just are you calling that, are you like interfacing that class through that other class?
Okay, so the question is, if your controller handles decrease, for example, let me try and explain this. So if your controller handles decrease and it receives that message via a button event, it knows how to respond to the button event and it knows how to change the data on the model. If you wanted, if you wanted to respond to a slider that knows how to increase and decrease, that's a different method, right? So I may have a method here called increase, a method here called decrease, which knows how to bump by one and take down by one. And I may have a third method called, let's call it slide age or slide number of sides, right? Which takes responds to a slider and knows how to change that value. The slider method wouldn't know what to do with the button because the button doesn't say the state, right? But the slider knows how many sides it should have. Does that help a little bit? Okay. Yeah, please.
So maybe one way to think about this is that a controller manages a set of related view objects and model objects, and it keeps them from needing to know too much about one another. So when the view, in this case, a UI button is pressed, it sends a message to the controller saying, hey, I'm going to invoke whatever action on you that I was set up with an interface builder. And from there, really, the controller is an object that you implement. And this is really the brain of your application. It decides what should happen when the button is pressed, whether it should go across the internet and ping some server and tell it to do something, or whether it's just going to maybe tweak some Polygon object that you've got stored locally. But the controller is where you write code that responds to, say, actions on the control, and then do whatever you need to do for the specifics of your application. The controller, I'll call it a glue. It sort of ties these related things together so that they can work together without knowing too much about one another.
Anything else? Okay, well, if that's it, that's MVC, that's Nibs. You should have everything you need to do your Hello Poly project, which, again, is due tomorrow. So good luck, and yeah, we'll see you on Wednesday.
For more, please visit us at stanford.edu.